Okay, so example 14 says if 4 minus the square root of 7 times 3 plus x times the square root of 7 equals negative 2 plus y times the square root of 7, where x and y are rational numbers, find the values of x and y. So sometimes when you're dealing with an equation, we want to make them relatable. And we've had a few examples like this before where it shows us on one side what we're trying to create and or what we can make with the left side if we know a little vision. So over here, right, this is like multiplying binomials, and we know how that's going to work, right? We're going to end up with 4 parts, and we can combine those into something. Um, you should be able to see that we will probably end up with some regular numbers and some number times the square root of 7. Well, look at what we have on the other side. We have some number plus some number times the square root of 7. If we can make both sides look similar enough to each other, we can actually um, make a statement about that. And so let's leave this side alone to start. And let's just look at this side. Right? It's not going to be possible to solve for 2 variables in one single equation, so we want to leave the one variable over there anyway. So if we make our box where we FOIL, whichever way feels comfortable for you, my first term is going to be a 12. My outside term is going to be a 4 times x times the square root of 7. Right? It's all multiplied together. The inside terms are going to be 3 times negative square root of 7, which we're going to call negative 3 times the square root of 7. So we can just reorder that, right, and just move the 3 up. The negative is like a negative 1. It can transfer like that. And then our last term is going to be negative square root of 7 times x times the square root of 7, which is going to make negative 7x. And of course, that equals the negative 2 plus the y times the square root of 7. So again, we're trying to make it look like this over here. So what we want is we want to get all of our square roots of 7 together, and we want to get all our other terms together. So I'm going to reorder this real quick. So I'm going to say, okay, my 12 and my negative 7x, we're going to move that up here. 12 minus 7x, and then we're going to say this stuff together. So we're going to say, okay, well, I've got plus 4x times the square root of 7 minus 3 times the square root of 7. Alright. So, you may say, wow, this is crazy. And it looks kind of weird. But we have things in a way that we can we're almost there to make a statement. So we see that we have our square root of 7 terms together. Well, they have that in common. The square root of 7s are in common to something else. And so what we can do, and I'm going to write it this way for simplicity. You can normally I like to factor out to the front of the statement, but it'll make more sense in a second while I'm doing this. And it doesn't matter because multiplication goes forwards and backwards the same. So if I take out the square root of 7, so I'm trying to make a term times the square root of 7. That's my goal. And because both of these terms have the square root of 7 in it, I can factor it out. Well, the first one has just a 4x remaining. So I write that inside the brackets, or inside the parentheses. The next one has a minus 3 remaining, or negative 3. And so I can rewrite that statement that you see in the middle with parentheses 4x minus 3, close parentheses, times the square root of 7. It's the same thing. And then I can consider this together, 12 minus 7x, as also kind of one term. So what we see here is that I actually have all the parts that I need, right, in order to make a statement now. Before, I wouldn't have been able to solve for these, but if I can kind of compare side to side, I can do this. And so now what I can say is, well, the square root of 7 is special, right? It can't just come from anywhere. And that's why this whole thing works. So what I can say is these two things are linked together. I can say at this point that if 4x minus 3 times the square root of 7 on one side equals y times the square root of 7 on the other side, then I can say, well, 4x minus 3 equals y. And on this over here, I can say, well, if 12 minus 7x on one side, and I've just got my negative 2 on the other, I can link those together. And it's all because of the pairing of the square roots of 7. So what we want to go with, these are simultaneous equations, but we can actually solve this pretty quick. This only has one equation, or one variable in it, so we're going to want to choose this to go first. So we'll get 12 minus 7x equals negative 2. So we're going to get negative 7x equals negative 14. So x at this point would become 2. And then if we take this and cycle it back into our main equation, we're going to get 4 times 2 minus 3 equals y. And so that's going to make y equal to 5. So this equation is fairly complex in that it's got a lot of stuff going on, and we have to kind of see ahead of time how we're going to go ahead and solve it. But this is a way that we can solve it, right? We can make two things look alike and then make comparisons, but we have to make them as identical as possible in order to do that.